So how do we handle this? Well, let's start off with what we already know. I know that 9 divides into 20. Whoops, I gotta turn that on. Let's see. 9 divides into 27 3 times and into 45 5 times. So I know I'm going to get a 3/5 in there. And one way to handle the V's and the W's is to say, do I have more V's in the top or the bottom? You'd say in the bottom. Well, how many more? 3 more. Cool. Do I have more W's in the top or the bottom? On the top. How many more? 1 more, which you don't have to put that. And you're done. And that's really it. Now, at some point, we'll get into negative exponents, but we can approach this slightly differently. But that's really all it is. It's just this top and bottom thing. Okay, so now we're going to find all the excluded values. In other words, all the numbers that when you plug them in to this expression don't work. They give you an error message if you do it on the calculator. Well, the numerator, that can be whatever you want it to be. So there's not going to be any restrictions there. But the denominator cannot be 0. When you try to divide by 0, things don't work out so well. Okay. So for example, if I say 9 divided by 0, doesn't work. I get an error. Okay. But if that's 0 in the denominator, in the bottom. But if I do 0 on the top of the fraction, yeah, it works. I get an answer. I get 0. No big deal. All right. So what does that mean for us? Glad you asked. Here's what it means. It means that the denominator cannot be 0. So let's just write that down. Okay. The denominator cannot equal 0. And now let's just solve, okay? So we've seen how to factor this guy here. I'm going to shortcut it because A is 1, as in 1 times W squared. And when A is 1, well, these have to both be W. And then I'm just looking for a couple of numbers that multiply to 36 and add up to -12. Going out on a limb here, I'm going to assume it's -6 and -6. And indeed it is. So then I set each factor to 0. And they're the same thing. So if I add 6 to both sides, I'm going to get 6 either way. So W cannot be 6. Okay, in this case, yeah, the answer was repeated, but usually these two numbers are different, and then you get 2 different values. But 6 is the number that's out of bounds. You plug in 6 to this little piggy right here, and you're going to get that error message. So let's simplify this guy. So this time we're not looking for what's out of bounds. We're just looking to tidy it up, simplify it. So it does give us a huge hint. It says, do GCF factoring. All right, that's always the first thing you should try anyway. Well, there is a greatest common factor in the numerator, and it's 5y. And if I factor out a 5y, I'm left with y minus 2. And in the denominator, I can factor out an 8y, leaving me with y minus 2. So the numerator has 1, 2, 3 factors. Factors are things that are multiplied together. And the denominator also has 3 factors. Well, they don't have anything in common except they both have a y. And they both have a y minus 2. And so this just simplifies to 5/8, and that's it. So factor out the GCF and cancel the factors that you can. Okay, so on this one, let's look at the second one first. So this guy down here, I think we can all agree that 2 plus 3 is the same thing as 3 plus 2, right? Yeah, because when you add, the order of the numbers doesn't matter. Okay, which means the first one I could rewrite as 4u plus 3 over, oh, wait a minute, this is not what I thought it was. Oh, poop, 4 plus 3u. Okay, well, they're not the same thing, rats. And there's no greatest common factors to pull out. So for this one, the answer would be cannot be simplified. Oh, how about that? Okay, cool. Well, how about this guy here? Well, I could rewrite it as u minus 3 over u minus 3. Notice the u is still positive, and the minus 3 is still minus 3. Okay, well, the top and bottom are the same, so I get 1. That's how we do it. Let's do another one. Okay, this one's just like the last one. I want something better. Maybe I should pause. Okay, let's do the first one. This first one looks, the top and bottom look, certainly similar, but certainly not the same thing. But notice, if I factor a -1 out of both terms on the top, I get that. I know I get that because if I take the -1 and multiply it back through, I get what I started with. Okay, so now I can cancel the w plus 5s and I'm just left with -1. Okay, on this one, I'm gonna change the color because I'm getting bored of that. So we want to factor it and cancel whatever we can factor. We can't cancel any common factors. So for that numerator, it's 3 terms. It's a trinomial. So I'm going to try the AC method. But it's 1 u squared out in front. Therefore, I can just shortcut it and say, well, they both have to be u. And then -5 and +1, that'll multiply to -5 and add up to -4. Okay, in the bottom, I can factor out a 4. Okay, which leaves me u squared minus 1. But I can factor u squared minus 1. That is the difference of squares. So when I factor that, I get u plus 1, u minus 1. And I can cancel the u plus 1s, and I'm just left with u minus 5 over 4 times u minus 1. And the problem is done. And as always, plug that in for y1, plug that in for y2, go to the table, see if they match, just to check your work. Okay, same thing. Factor, cancel the common factors. All right, well, the denominator has that 1x squared, so I'm going to do the shortcut just to speed things up. And once again, I get -6 and -6, just like earlier in the video. Now, the numerator has this -2 out in front. It's not +1. So what I'm going to do is I'm going to factor out, well, I can factor out, I was going to just factor out -1 so that this becomes a positive, but I can factor out a -2. So might as well. If I do that, I'm left with x squared minus 5x minus 6. And then when I factor that resultant trinomial, I'm going to get -6 and +1, I think. That'll multiply to -6 and add up to -5. Yeah. All right, so I can cancel those little guys, and here's my final answer. Bam, just like that. Okay, on this one, so the new, again, they are both trinomials. There's no greatest common factor there or there, so I can't factor anything out immediately. So I just have to go to AC method. On the first one, I'm going to get x minus 3, x plus 2. Okay. Now this second one, I've got that 2 there, and I can't just factor 2 out of everything. So I'm going to actually do the AC method. Okay. So the AC method says, oh wait, I should probably change colors just to make it really exciting. says I'll go a times c, which is 2 times negative 10, which is negative 20. So 1 and 20, 2 and 10, 4 and 5. But they need to multiply to a negative, so they need to be oppositely signed, and they need to add up to a negative 1, so the big one is negative. And let's see, so there's the pair that adds up to negative 1. So I can rewrite 2x squared minus x minus 10 as 2x squared, let's do plus 4x minus 5x minus 10. And then I will slap in some parentheses. Factor out a 2x out of the first binomial. Factor out a negative 5 out of the second binomial. And because I picked the 4 and the negative 5, the stuff in the parentheses matches. So I can factor out an x plus 2. I'm left with 2x minus 5. And now I know how it factors. X plus 2, 2x minus 5. The x plus 2's cancel. And my final answer is x minus 3 over 2x minus 5. Okay. So this time, let's check it on the calculator. Okay. So I will go to y equals and plug in the original problem. So 1, negative 1, negative 6. So x squared minus x minus 6 over 2, negative 1, negative 10. Okay, and I claim that's the same thing as, well, what we got for our answer, which was x minus 3 over 2x minus 5. Okay, I think it's time to do some erasing. Okay, there, erased. Okay, so let's go to the table, see if they match up. And it sure looks like it. And if I'm not satisfied, I can keep looking around. Again, they didn't match up right there because there was another factor in the denominator for the original problem that got canceled away, and that factor is not there for the final answer. So that's okay. That's not a problem. Okay, so they match, so I know I haven't made any mistakes. And that's how we do it. Yaha.